So we're now going to focus our attention on improper integrals that are type 2. And in this case, your upper and lower bounds are still going to be real numbers. They're both going to be real numbers, but the graph itself will either go to positive or negative infinity. So in this diagram I have here, we're looking at the function y equals 1 over the square root of x. Well, as the x values approach 0, the function itself is going to go to positive infinity. So again, the upper and lower bounds are real numbers. It's the graph itself that's going to go to infinity, or in some cases, negative infinity. The way that we're going to tackle this, the way that we're going to handle this, is by, again, setting up limits. And in this case, we're going to replace the real number where the graph goes to infinity or negative infinity with either an a or b, depending if it's the upper or lower bounds, and then look at the limit as either a or b goes to that real number. It's much easier to show you an example, so I'm going to do that. But I have the definition of exactly how this works, but it's very similar to what we did before. Again, it's just that your upper and lower bounds don't go to infinity, it's the graph itself. So let's look at this first one here. We're looking at the integral from 0 to 1 of x times the natural log of x dx. Well, you probably know you can't take the natural log of 0. Why? The graph goes to negative infinity. So in this case, it's that lower bound 0 that's going to be our problem area. So what I'm going to do is I'm going to replace it with an a, and we're going to look at the limit. Oops. There we go. It helps if my pen is turned on. We're going to look at the limit as a goes to 0. And then it's going to be the integral, not from 0 to 1, sorry, but from a to 1, x times the natural log of x dx. There we go. To integrate this, I'm going to use integration by parts. I'm going to let u equal the natural log of x, so that du is 1 over x. And I will let v prime equal x, so that v is 1/2 x squared. So what are we looking at? We've got the limit as a goes to 0 of uv, so that's 1/2 x squared times the natural log of x, and we're going to evaluate that from a to 1, minus the integral of v du, so we have 1/2 x squared times 1 over x, that's just going to be 1/2 x dx, and that's going to be evaluated also from a to 1. So, write my limit out and see where we are. If I substitute in a 1 for x, I get 1 squared times the natural log of 1. The natural log of 1 is 0, so that whole term is just going to be a 0. So then we're going to have minus 1/2 a squared times the natural log of a, and we will look at that limit in a little bit. Over here, when I integrate 1/2 x, it's going to be 1/2 times x squared over 2, so we end up with 1/4 x squared. And again, we're going to look at that from a to 1. So one more time, the limit as a goes to 0 of negative 1/2 a squared times the natural log of a, minus, I've got 1/4 times 1 squared, well that's just 1/4, so it's going to be minus a 1/4, and it's going to be then minus 1/4 a squared, but since I have the negative in front, negative and a negative make a plus 1/4 a squared. Now, taking the limit. The negative 1/4 doesn't have an a, so that's going to stay negative 1/4. The third term, as a goes to 0, so does the entire third term. The first term, however, that's an indeterminate form, so we're going to go back to our friend L'Hopital, and we're going to use L'Hopital's rule here. And let me switch colors again. The negative 1/2 doesn't impact anything, so I'm just going to look at the a squared times the natural log of a. So if we're looking at the limit as a goes to 0 of a squared times the natural log of a, well, I could rewrite this as the limit as a goes to 0 of the natural log of a over 1 over a squared. And again, algebraically, these are both the same, just rewriting it to create a fraction. L'Hopital's rule says that I can differentiate the numerator and differentiate the denominator. And so if I do that, I'm going to get 1 over a. And in the denominator, 1 over a squared is a to the negative second. So if you differentiate that, it's going to be negative 2 over a cubed in the denominator. And algebraically, if you rewrite this, you're looking at the limit. I apologize, that's my cat in the background. You're looking at the limit as a goes to 0 of negative 1/2 a squared. And as a goes to 0, so does this. Okay, so this is going to go to 0. Sorry, that's supposed to be an equals. So that tells me that this entire first term goes to 0, because if you take negative 1/2 times 0, it's still 0. So the whole first term is going to go to 0. The last term goes to 0. The only thing left is what's in the middle, and that's a negative 1/4.